All right, this is a video about frequency distributions and graphical representations of those, which are histograms and ogives. So a frequency table partitions data into classes or intervals and shows how many data values are in each class. The classes or intervals are constructed so that each data value will fall into exactly one class, so we don't have any ambiguity or overlap between the classes. The class width is determined by the following formula. We take the largest data value minus the smallest data value and divide that by the desired number of classes. Now, in our class, we will have directions about how many classes to use, but if you were doing your own study or your own statistics collection of data, you would determine this based on what you think represents the data the best. We'll round this value up to the next highest whole number. That's to make sure that we get all of our data values included in a interval and that we don't have something that falls outside of that. The lower class limit is the lowest data value that can fit in a class. The upper class limit is the highest data value that can fit into a class. Class width is the difference between the lower class limit of one class and the lower class limit of the next class. So when we're doing our class width, we'll be adding that value to find the starting point of each class limit. The midpoint, which is very useful when we want to do sometimes the histogram, maybe we want to graph it by boundaries or we might want to graph it by midpoint. The midpoint is found by taking your lower class limit for an interval plus the upper class limit for that same interval and then dividing it by 2. So you're trying to find the middle between the class interval, lower and upper parts. The class boundaries. Now, this is important if you're going to do the histogram because the bars are supposed to touch in a histogram. So we don't want the ambiguity of does a value belong in the first bar or the second bar where if it's on that place where they touch. So we add, if we have integer data, we add a half and subtract a half from each limit, our class limits, to get those class boundaries so that when we graph our histogram, the place where the bars touch is not an actual data value. So that's just found if we're doing integer data, which we will be in this example, we add and subtract 0.5 to the lower and upper class limits respectively. Relative frequency is related to probability and percentages. We learned about that in class. Relative frequency is equal to the class frequency divided by the total of all frequencies. So that class frequency for that specific interval divided by all frequency of the data. The cumulative frequency for a class is the sum of the frequencies for that class and all the previous classes before it. So it's accumulating up to a certain point. And we already kind of mentioned that histogram is a bar graph that is used to show the frequency of numerical data where the bars actually touch. An ogive is a line graph that shows the cumulative frequencies. So we'll show you how to make one of those. And then sometimes you're asked a follow-up question about the shape of your distribution. So your shape could be mound-shaped or symmetrical. Uniform, which is kind of like all the bars are the same height, so it's rectangular. Skewed left means you have some really low data values that are bringing your average down. So what you'll notice is you'll have a tail that extends much further to the left than it does to the right of the mound. Skewed right, you'll have a tail that is much further to the right, spread out than the one to the left. And that's also when you have really high values that are pulling your average up. And then you could have multi-peaks or multiple, the mode, essentially the frequency. That bimodal data would be 2 distinct peaks that are very high. You could have multimodal. So, but we're only going to mainly see bimodal. So let's look at an example to kind of tie all of these definitions together. So we have certain kinds of tumors tend to reoccur. Following data represents the length of time in months for a tumor to recur after chemotherapy. The lowest, I've already ordered these from least to greatest. The lowest it is 1 month up to 59 months that they had data for. Quick thing to note, you should always know how many total items are in your list. So this is 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like we have 40 as our N. I'm going to just kind of write that down. We'll need that when we do relative frequency. So for this problem, we want to use 5 classes. Okay, so that's going to be important to find our class width. So for class width, we take the highest data value minus the lowest data value, which is a 1, so 59 minus 1, and we divide that by the number of desired classes. So that's going to be 58 divided by 5. So we'll get our calculator. I already did it once, so let's check it. It's 11.6. And notice that even if that was 11.4, 11.3, 11.7, whatever it is, when you're doing class width, we always round this up, okay? So my class width for this group is going to be 12. Now, why is that important? That's going to tell us how to set up our class intervals. So for this part B, we're going to make a frequency table, which is this table right here showing our class limits, class boundaries, remember, which are used for graphing the histogram, midpoints, which could also be used for graphing a histogram. Sometimes they're used when we use them for estimating mean and standard deviation later on. So we'll see this again. Frequencies, relative frequencies, and cumulative frequencies. And we do have a special note to round our relative frequencies to 2 decimal places. Okay, so the lowest value in our list was a 1. To get and we don't worry about the top part of this class limit yet. We're going to get all of our lower class limits first. So we're going to add 12 to get to the next lower class limit. So that's going to be 13. Add 12 again, we're going to get 25. Add 12 again, we're going to get 37. Add 12 one more time, we're going to get 49. Now, your upper class limit in each group, because remember, this is an interval that contains multiple things from our list up above. It's one integer if we're doing with integers less than the lower class limit of the next group. So that'd be 1 to 12, 13 to 24. And notice these are going up by 12 as well. So this is going to be 36, 48, and 60. Note that if we had not rounded up to 12, say for some reason that had been 11.2 and we would have rounded down and somebody rounded down to 11, we might not have reached a high enough value in our last limit to make sure that all of our data, which we're going to go back up and look at, would fall into a class interval. So 59 was our highest data value. Notice it's in that last group. The class boundaries, we take a half point off in each direction of these integers. So that would be 0.5 to 12.5. Notice this will also be 12.5. It's okay for these to overlap because remember that's where the histogram bars are going to touch. There is no actual 12.5 in my list of data. And then the half step up would be 24.5. 24.5 to 36.5. 36.5 to 48.5. 48.5 to 60.5. Okay, to find your midpoint, you can add your lower class limit and upper class limit together and divide by 2. So 1 plus 12 is 13, divided by 2 is going to be 6.5. So that would be the midpoint for this group. If we do another one, let's see, 13 plus 24 divided by 2, that's going to be, let's see, that'll be 37 divided by 2. That's going to be 18. No, that's not 18. Let's see, let me double check that. 37 divided by 2. Yeah, it's 18.5. Okay. Just questioning, doing my math in my head. But anyways, after you do 2 of these, you'll notice a trend. This is also increasing. If everything's uniform over here, this is going to also be increasing by our class width of 12. So we could just keep adding 12 to get the rest of these, or we can do it by the formula. So that would be 30.5 is halfway between 25 and 36. Add another 12, that's going to be 42.5 is halfway between 37 and 48. And if we add 12 again, we get 54.5. So there's all of my midpoints. Okay, frequencies. So we're going to have to go back up and look at our table. So 1 to 12, and sometimes I like to mark these off as I go. Maybe I'll use different colors to represent. So from 1 to 12, we have 1, 2, 3, 4, 5, 6 items. So we're going to put that had a frequency of 6. We'll just write that number in. Some people do tallies, but we want to write the actual frequency as a number. 13 to 24. So let's change colors. So that would be 1, 2, 3, 4, 5, 6, 7, because that's over 24. So there's 7 items in that group. Okay, now we're moving 25 to 36. So 1, 2, 3, 4, 5 items in that group. Now we need to go 37 to 48. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, quite a bit in that group. And then our last group, the frequency is from well, how many items or how many tumors reoccurred in 49 to 60 months. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice that most of the tumor reoccurrence frequency happens here towards the post 4 to 5 years kind of mark. We see a lot more frequency there. So that's why a lot of times they follow up multiple years after someone has had cancer. So relative frequency, so to find that, I'm going to do each of these in its own color, just like we did before. We first have to know our total frequency, which was 40, remember? So we take 6 and divide that by 40, and we're going to get that to 2 decimal places if it needs to be rounded. So 6 divided by 40 is 0.15. So that was already 2 decimal places. For the 7, so 7 divided by 40, that one we'll have to round, so that'll be 0.18. Then we're going to do 5 divided by 40. Or that's our total frequencies. That's 0.13 if we round. Then we're going to do 13 divided by 40. So 13 divided by 40 is about 0.33. And then 9 divided by 40. So this will be our last relative frequency. So that's about 0.23. Now, notice that I had to round up in every single one of those based on the rounding rules. So this should normally add to 1 for 100% essentially, but we're going to add up to more than that because every time we needed to round, you'll note that we had to round up based on the rounding rules. So notice this will be a little bit more than 1. I just want to verify and show you that. Oops, back up out of that. Plus 0.23. Notice that we're like 1.02, and that's because we had all of that rounding up, okay? So normally, if you kind of have a balance of rounding up and rounding down following your normal rounding rules, you'll see that that adds perfectly to 1. If you're rounding down every single time, you might be at 0.999, so you just have to realize it's supposed to be really roughly close to 1. Based on rounding, we could be a little off, okay? Now, cumulative frequencies is a little different. We're just listing the frequency at that moment in time plus any previous frequencies. So for this one, once we get to the end of this limit, which is 12, we've accumulated 6 items in the list. Once we get to 24, we've accumulated 6 plus 7, which would be 13 items. Once we get to 36 in the data list, we would have accumulated the 13 before plus the 5 more. So we've accumulated 18 items in our list. And then when we get to 48, so the end of this limit, we will have accumulated 18 plus 13. So that's going to be 31. And then notice that the last group, we accumulated 31 up to this point plus 9 more. Once we get to 60, that should equal the total number of items in our entire data set. So this is the cumulative frequency count. Okay. So we want to now draw a histogram and a relative frequency histogram. I put both here because they look very similar. It's just the y-axis that changes. So a histogram is just when you use the frequencies. So you're going to have, you need just an x and y axis, usually just one quadrant because everything's positive. We're going to label the bottom with our class boundaries because in a histogram, remember, we don't want those bars to be gaped between them. So if we just went from 1 to 12 and then 13 to 24, there'd be a 1 unit gap in between. So that's why we use those class boundaries. So we're going to label 0.5, 12.5, try to make these evenly spaced, 24.5, Then we'll have 36.5, and then 48.5, and then 60.5. The highest frequency we got to was 13, so maybe I'll count by twos on my y-axis. So this is going to be my frequencies. So say 2, 4, 6, 8, 10, 12, 14. Our graph should have a title. So this is months down here, since the other part's frequencies. And this was reoccurrence or reoccurring tumor after chemo. That's what we're measuring. Okay, so we're going from 0.5 to 12.5 for this first class interval, and we needed to have a frequency of 6. So that's the height of our bar on that class boundaries list. Okay. And again, if you're drawing this on paper, you can use a ruler, make things look nice and straight. Then we had 7, so that's about halfway between 6 and 8 for the next group. So from 12.5 to 24.5. And then we had 5 items from 24.5 to 36.5. So that's going to be halfway between 4 and 6. Then we had 13 items, so that's going to go up really high from 36.5 to 48.5. And then we had 9 items in our list from 48.5 to 60.5. So notice that is the histogram for this specific frequency level. Now, to do a relative frequency histogram, essentially the graph's going to look identical in terms of the shape and how this is listed and what bars we see and even their height. The only difference is, because we're not changing anything about our class widths or what our intervals look like, we're going to be having the relative frequency values on the y-axis. So that's the big difference. So these are going to be those, essentially this is like the percent as a decimal. So we would have the same title, reoccurring tumors after chemo. And this is still months down here. We need to put our values, so 0.5, 12.5, 24.5, 36.5, 48.5, and 60.5. Then on this side, notice the highest decimal, or if you want to think of them as percentages that we get up to, is about 33, so 0.33. So maybe I want to count by 0.05. So 0.05, 0.10, 0.15, 0.20, 0.25, 0.30, and then 0.35. Okay, so we get up to 15 on the first group. And notice I'm not exactly the same scale here, but you're going to see that the shape is the same as this. The heights of the bars will be proportionate as they are here. Then we get to 0.18, which is closer to 0.20. Then we had 0.13, which is going to be below this. 0.33 is going to be way up here. And then 0.23, about halfway, a little over halfway. So notice that is, even though my scaling is not perfect because I don't have a ruler or graph paper, you see the same proportional changes in those bars. Now, the follow-up question for that then is, what is the shape of this distribution? Well, it's not uniform because it doesn't have just a straight kind of line across. It's not symmetrical because we don't have the mound in the middle with equal bar kind of spacing on each side for the tails. It's not really bimodal because you need both peaks. There is a secondary looking peak here, but the peaks need to be similar heights. So what we're looking at is that we have kind of a mound here and a tail stretching much more to the left side than it does to the right. So this data would be skewed to the left. All right, so the last piece that we want to do on this specific problem is draw an ogive. So an ogive is really a line kind of graph, and we're going to set it up using our class boundaries again. I'll draw this one a little bigger since I have a little more room. So we have the recurrence of the tumors after chemo, still the same title, because that's what we're talking about. That's what we're giving the graphical representation of. But over here on the side, we're going to write cumulative frequency instead of just frequency or relative frequency. And let me go back for just a second. I don't know that I wrote relative frequency on the last one. I did. Okay, just making sure. So cumulative frequency, and then down here at the bottom, we'll still start out with our class boundaries. That's important to use this specifically for the ogive. So 12.5, and then 24.5, 36.5, 48.5, and 60.5. This was, remember, the months. Okay, now the cumulative frequency should go up to the total number of frequencies, so it needs to go all the way up to 40. Maybe I'll count by fives on this. So 5, 10, 15, 20, 25, 30. Oops, that's a little too close for that last one right there. Might remake my line bar. I'm gonna have to even this out. Only thing bad about using a tablet, you erase one thing, it erases everything. So 5, 10, 15, 20, 25, 30, 35, and 40. That's a little bit nicer spacing. Okay, so the reason I said you need to use your class boundaries, notice we have 5 classes that we would have done histograms in, but actually we had the starting and stopping, which these, remember, overlaps because they're class boundaries. That's kind of where those histogram bars would have touched, but that's not actually a data value. These allow us to help us find those accumulating points where at that point in the moment, if we stopped, we would have added that many items from the list to our set of data. Now, why that's important is the very first one should always be the lower class boundary. This is before any data in the list, because remember, the lowest data point was a 1. So before we got to any data in the list, we had 0 accumulation. So the very first point on any ogive should be the lowest class boundary, that's before any data, and it should be plotted at 0. Once we got to the end of that first class interval, remember we had accumulated 6 items out of the list. So notice we're going to plot that point at just a little bit above 5. And then we draw a line connecting them, a line segment. Then when we get to our end of our second interval, so this 24.5, we've accumulated not just 7, but 6 plus 7. So we've now got that 13. So that's going to be plotted as the next point. So right above halfway. And then we draw a line connecting those. And then by 36.5, we had accumulated up to 18 items in the list. So just a little under 20. Then we had a huge jump because we had 13 new items added in this group. So now we've accumulated everything before it up to now 31 items out of the total list. So that would be all the way up here. And then finally, by the end of the list, 60.5, we've accumulated all 40 items. So what you see in that ogive is you can see these little kind of line segments. You can kind of see that the slope is steeper. We have a lot bigger steep slope when we have a lot of frequency added in a specific class boundary to class boundary. So that is how you do all of the things that are related to frequency distribution tables and how to make a histogram and an ogive. I hope this was helpful.